Okay, this is lesson 3.1 on measurement. And for a warm-up, we had some conversations about like how can we quantify the world around us. And the word quantify means assign values to. And I don't mean values as in like moral value, like this is good or this is bad. What I mean is assign values or numbers to things. Right? So what are some ways we could do that? And so some of the ideas that people came up with is like you could weigh something, right? So you could weigh something and see how heavy it is. You could see like how much water it would hold. And that would be measuring the volume. So we can look at weight, we could look at volume, we could measure how long something is. So now we're talking about distance. We're measuring distances. Let's see, were there any others? Oh, we could do temperature. Right, so we can give a value for that. What are we supposed to be like? A person's supposed to be around 98.6. It's not exact. It changes from person to person, but I think that's the general number. So there's a lot of different ways that we could quantify or assign values to it. And in this one, we're going to talk about measurement. And we talked about different things that we could measure around the classroom. We talked about the tables that students were sitting at. As one example, and we'll use that example later on in this lesson. But for measurement, I want to talk about two types of measurements. For the rulers that we're going to be using, we have both centimeters and inches. And this should say centimeters, decimals. I should probably just spell it centimeters for this, since it is notes. Centimeter. So these are centimeters that you would see on a regular ruler, and then on the flip side you're going to see inches. And they are different. One of the most common mistakes I see is people measuring in inches and then trying to put decimals with it. And inches are done in fractions. We'll talk about why in a second. But we're going to take a look at centimeters. If you look at centimeters, going from one number to another, there are 10 jumps. So if I start here, I'm going to go 1. Let me zoom in. So we're really taking a close look at that. All right, here we go. So if I'm going to go from 4 to 5, I can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 movements from 4 to 5. Because of that, if you were to measure something and you were to go like 3 movements past it, this would be 4 and then 3 out of 10. Because there's 10 total movements to the next number, you're only doing 3 of them. So when I talk about then, 4 and 3 out of 10, well, that's a fraction. But this fraction easily converts to a decimal. Sorry, my camera here is auto-focusing on its own. This is the same thing as 4.3. If I did 3/10 on a calculator, it's just 0.3. So why use a fraction when the decimal is so much simpler? So when we measure in centimeters, we use decimals because there are 10 jumps between centimeters, which means your fractions would be out of 10. And when something's out of 10, it goes right to a decimal because the decimal system, deci means 10, right? We've talked about that before. Now, inches, not the same. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 jumps from 1 inch to the next inch. So when we do a measurement, if I counted 3, very similar to what I did here, if I had like 4 and then I had 3 tick marks past that, whatever inch it is, it's out of 16, not 10. And you don't want to convert that to a decimal because it's not better. 3 divided by 16 is 0.1875. That's not simpler than this. So when we do measurements with fractions, we do them in, when we do measurements in inches, we will do them with fractions. And when you do measurements in centimeters, you will use decimals. So I'd like you to go ahead and measure these two lines in both centimeters and inches, and label the centimeters on top and the inch measurement on the bottom. Remember, this should be a decimal, and down here, this should be a fraction out of 16. I want to point out one other thing before you begin. Notice these numbers here, they don't have 16s in the bottom. That's because if you count an even number of times, you're going to get a fraction that reduces. Notice all of these down here that have 16s. 1, 3, 5, 7, 9, 11, 13, 15. All odd numbers. If this is 1/16, this is 2/16. Well, 2/16 reduces. Cut it in half. 1/8. Boom, 1/8. Here, this is going to be 4/16. 4/16 reduces to 1/4. 6/16 reduces to 3/8. 8/16 reduces to 1/2. So all of these numbers they count it over, and then they reduce the fraction to its simplest form. If you're not sure, remember, just plug it into your calculator. You do your counting. If you get a 10/16, you can put 10 over 16 in your fraction, hit enter, and it'll reduce it down for you. All right, go ahead and do the measurements for those two lines, and then we will check to see how you did. All right, so hopefully you're done with those measurements. I'm going to go ahead and perform them now. I'm going to start with centimeters first. So when we line up, you'll notice the edge of the ruler is not where we start the measurement. And they do that in case the edge of the ruler gets nicked or chipped or whatever. You still have a good line to measure with. So I'm going to set this up at the very end of the line. I'm going to come over here. And man, that looks pretty close to 12, doesn't it? I'm getting 11.9 though on mine. So I think I'm going to go 11.9. 11.9. Now, every measurement you make is an estimate. There are no perfect measurements. They don't exist. At some point, you're guessing. And so at here, I think it's like just a little bit past 11.9. I don't think it's closer to 12. But it's definitely more than 11.9. So, but I don't know 11.9 what. I have no idea. I mean, I could guess. Maybe about 11.93, 4. I'm not really sure. Now there are better tools. There are more accurate tools. The better your tools, the more accurate your measurement can be. But there's nothing exact. At some point, even really precise tools are guessing at some point. All right, and then since I'm already on centimeters, I'm going to go and do the bottom one as well. So this one here, I'll line up at the edge. And here I'm getting, looks like 5. Let me move that over. I'm getting 5.1 here. Now, if you're 1 unit away from mine, like if you got, I don't know, if you got closer to 12 on that, I think arguments could be made for it. Like I said, it's a guess. So for the measurement pieces, as long as you're pretty close to it, try to be as precise as you can. Make sure you're lining up that line at the very beginning. But I think this is not quite 5.1, but I think it's closer to 5.1 than 5.0. And so if there are situations where it's really hard to tell, I will give you the benefit of the doubt. If it's real obviously one or the other, on that one, you have to be exact. But if it's real close, just make your best guess, and I'll know which ones are real close. Right, let's go and do inches. I'm going to line up the inches here on the first line. Line that up. All right, so we're definitely at 4, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Looks like I got 11. It looks maybe a little bit past 11, but certainly not closer to 12. So that's going to be 4 inches, and then 11 is my numerator, and then remember, 16 is my denominator, and we're going to leave it as a fraction. And then for the bottom one, set up the measurement again. That looks like 2 inches. That looks really, really good. So we're just going to put 2 inches. Is it perfectly 2 inches? I don't think so. No, I think it's just maybe a little bit past. But it's certainly closer to 2 inches than it is 2 1/16 of an inch. All right, let's flip the page. So in this one we're measuring angles. We're going to have to extend these lines. Unfortunately, protractors will not reach all the way over, so I'm going to have to extend the lines a little bit. If you're using a later set of notes, this may have already been done for you, but this is I'm using my first version for this video, and on my next version I'm definitely going to extend these out so we don't have to spend time doing that. But if you have to do that, just place your pencil on the line, make sure it's on the line in a couple spots, double check, and then make sure you're drawing along the line pretty clearly before you extend it. Right, and then I'm going to do the same thing for the other two. So I'll pause this so you don't have to watch me do this, and then finish it, show you how to use the protractor for it. You'll need a protractor to do the measurements. If you don't have one at home, we can go over this in class, or you can borrow one in class to do this, and then just check the answers with it. So for this, you want to make sure that, first of all, that the numbers are right side up. We're going to be using the outside. Notice your 0 is right here. This is 0, 10, 20. It does count 0 and goes over like 10, 20, 30 from the other direction, but they don't have the smaller tick marks here. And so I don't usually use that side, which means when I line up, I have to line up this line here with this side so that I get a measurement off of this other angle. And then what I'm doing is I'm lining up this line with the line, this side of the angle, and I need the tip of this, the vertex of this angle, right in the middle of this circle. So you notice there's a line here, there's a line there, kind of a little like a crosshairs where you can try and get that right in the center there. And you might have to do a lot of little adjustments, like you move this and then that will move, you move that and then this will move, so you might have to just spend a little time moving it around until you feel really good about where you've placed it. All right, I feel pretty good about that. All right, so if I come right here, I look, well, there's 40, so that's 39, 38, so I feel pretty good about 38 degrees. Notice it's not all the way to 38 degrees, it's just a little bit on this side of it. 38's close enough, so we'll go ahead and write 38 degrees here. And remember, this is not a measurement. This is not inches or centimeters. This is degrees. So it's describing how wide this angle is. Now, the further out you go, the more distance there is between the sides. But this angle is the same all the way out. So this measurement is 38 degrees. Now we'll go to the other one here. Once again, I'm going to line this up. I'm going to start at the left side of the angle. And then I'm going to try and get that center in there. Get it lined up with the line. This one a little quicker. And now if I come over this way, what are we thinking? 142? I'm thinking 142, this line. So there's 140, 141, and 142. That looks pretty close. So we'll call this 142 degrees. All right. So I'm going to go ahead and pause this video. We're almost at the 15-minute mark, and have you go ahead and continue with part 2.